observe STP topology changes and implement RSTP. Spanning tree protocol and rapid spanning tree protocol. This topology. I will use GNS3. Okay. So I will use Cisco IOU L2 image, 3 switches, D1, D2, A1, D1, D2, A1, D1, D2, A1, okay. Between D1 and A1, gigabit 5 and 6, host Ethernet 1 and 2. I will use Ethernet 1.1 to Ethernet 0.1 and Ethernet 1.2 to gigabit 0.2. Okay. Ethernet 1.1 and 1.2 to Ethernet 0.1 and 0.2. Then another link between D2 and A1, gigabit 5 and 6 to fast Ethernet 3 and 4. Okay, gigabit. I will use Ethernet 1.1 to 0.3 and Ethernet 1.2 to 1.0. Okay, Ethernet 1.1, Ethernet 1.2, Ethernet 0.3, and Ethernet 1.0. Between D1 and D2, gigabit 1. I will use Ethernet 0.1 and Ethernet 0.1. Okay, very good. Addressing table D1, D2, A1, VLAN 1, 10.0.0.1, 10.0.0.2, 10.0.0.3. The potential effect of a loop in Layer 2 network is significant. Layer 2 loops could impact connected hosts as well as the network equipment. Layer 2 loops can be prevented by following good design practices and careful implementation of the spanning tree protocol. You will observe the operation of spanning tree protocols to protect the Layer 2 network from loops and topology disruptions. The terms switch and bridge will be used interchangeably through the lab. Required resources on real lab. I'm using image Cisco IOU L2. Build the network, ready. Cable the network, ready. Configure basic settings for each switch. Okay, copy switch D1, switch D2, and switch A1. Copy this to Notepad. Paste. Okay, switch D1. switch D2, switch A1, okay, host name, the mode per VLAN spanning tree, banner, line console, shut down all interfaces. Okay, what interfaces? I'm using D1, 0, 1, 1, 1, and 1, 2. Okay, Ethernet 0, 1, and Ethernet 1, 1, and 1, 2. Switch port mode trunk no shutdown. And shut down all interfaces from Ethernet 00 to 03, 10, 13 to 0 to 3, 30, 33. Okay. From Ethernet 00 to 03, Ethernet 10 to 13, Ethernet 20 to 23, Ethernet 30 to 33. VLAN number 2 name, second VLAN, interface VLAN 1, the IP address, no shutdown, then exit. And for switch D2, banner spanning tree, line console, shut down all interfaces, so use the same command here. And the trunking ports are E01, 11, and 12. The same ports on D1, E01, E11, and 12. VLAN number 2, second VLAN, VLAN 1, IP address number 2, switch A1, hostname, banner spanning tree, line, shut down all interfaces, so use the same range. Shut down all interfaces. And interface range from 1 to 4 trunk. But in my case, 01, 02, 03, and 10. Okay. Ethernet 01, 02, 03, and Ethernet 10. Switch port mode trunk no shutdown, second VLAN, and IP address number 3. Very good. Enter global configuration mode and apply the basic settings. Okay, start D1, start D2, start A1. Okay, go to D1. Enter and configure terminal. The notepad Okay, and review this hostname, spanning tree, banner, line console, interface range, shut down all interfaces, interface, here should be range, interface range 01, 11, and 12, 01, 11, and 12, trunk, no shutdown, VLAN 2, name, interface VLAN 1. Okay, but here you can do the following on this layer 3 switches, switch, port, trunk, encapsulation.1q. Okay, you need to specify the encapsulation before to configure the trunk. I'm gonna shut down. Okay, so you need this on all configurations. Interface range for D2, for A1 on trunking. Okay, this command before mode trunk. Okay, and now this is the final configuration for my IOU L2 image, and copy this, go to D1, global configuration mode, right click to paste. Okay, sorry, copy, right click to paste, enter. Hostname, spanning tree, banner, line console, shut down all interfaces, enable trunking, and VLAN number 2, interface IP address 1. And go to D2, configure terminal, create hostname, banner, spanning tree, shut down, encapsulation mode trunk, very good. Copy, right click to paste. Okay, banner, hostname, line console, shut down all interfaces, mode trunk, VLAN number 2, interface VLAN 1, 10.0.0.2, very good. And go to A1, configure terminal. And review this, and copy, right click to paste. Okay, hostname, banner, line, shut down, trunking, VLAN, interface IP number 3, very good. Outputs and spanning tree topologies highlighted in this lab may be different. Okay, discover the default spanning tree. Your switches have been configured and interfaces have been enabled, and a spanning tree protocol operational by default has already converged onto a loop-free logical network. We will discover what the default spanning tree looks like and evaluate why it converged the way it did. We will do this by following the same set of steps that the spanning tree does. We will find the root bridge, then find the root ports, and lastly see which ports are designated ports and which ports are non-designated ports in our topology. Find root bridge. Our switches are running the Cisco default per VLAN spanning tree plus, and we have 2 VLANs in the network. So we should see the 2 root bridges. On A1, show spanning tree root, and observe what the output tells you about the root bridge. Okay, go to A1, here to A1, and show spanning tree root. Okay, this is the root ID for VLAN 1 and root ID for VLAN 2. And the root cost is 100 in my case, and using Ethernet 01. Okay, this port Ethernet 01. So maybe D1 is the root bridge. Okay, maybe. A1 shows the root ID with a cost of 19. In my case, is 100. And the root port has the interface, in my case, is Ethernet 01 for both VLAN 1 and VLAN 2. Okay, in the lab, fast Ethernet 1, but in my case, Ethernet 01. This interface. Because we know from the physical topology diagram that A1 is connected to D1 using Ethernet 01, and that interface is an Ethernet interface. Therefore, having a cost of, in my case, 100, D1 is the root bridge for both VLAN 1 and VLAN 2. The question at this point is why? The root bridge is selected based upon which switch has the highest bridge ID. The BID is made up of a configurable priority value which defaults to 32,768, and the base MAC address for the switch. Use the command show spanning tree root to gather that information from your switches to support the root bridge decision. Go to D1. Show spanning tree root. Okay, go to D1 and show spanning tree root. Okay, this is the root ID. Okay, 32,769. Okay, the default is 32,768 plus 1 is 69, and the MAC address. Okay, here and the default is 32,768 with plus 2 is 32,770. Okay, this is the root ID. The priority, the VLAN, and the MAC address. Root cost 0. And root port, no root port, so D1 is the root bridge. On D2 and on A1. Go to D2 and show spanning tree root. Okay, the root ID, root cost 100 with root port Ethernet 01 for VLAN 1 and VLAN 2, Ethernet 01. Okay, D2 This is Ethernet 01, so D1 is the root bridge. Okay. And here on D1, you can see this is the MAC address AABBCC000100. And go to D2, and the root ID for the root bridge is AABBCC000100, the MAC address, the base MAC address of D1. And go to A1, and repeat, show spanning tree root. And now you can see the root ID is AABBCC000100, the MAC address, the base MAC address of D1. And the root port Ethernet 01. So Ethernet 01 is the root port, so D1 is the root bridge. The first thing to look at is the priority value. It is 32,768 by default. Because we are working with per VLAN spanning tree plus differentiator is added, the priority value is modified with the extended system ID, the VLAN, or extended system ID, which is equal to the VLAN number. You can see in the output here that our 3 devices are using the 4 priorities 32,769 for VLAN 1, that is 32,768 plus 1, and 32,770 for VLAN 2, that is 32,768 plus 2. For each VLAN, the priority values are the same for each of the 3 switches. When this happens, the rest of the BID is taken into account. The rest of the BID includes the base MAC address. The lowest base MAC address is used to break the tie. What are the base MAC address for the devices we are using? Short version, pipe, include MAC. Okay, on 3 switches. Go to D1, show version, pipe, include MAC. Okay, only show version. Show version is not including the MAC address. So you can use show spanning tree, enter, and you can see on VLAN 1 the bridge ID. This is my local MAC base MAC address, AABBCC000100. Okay, and is the same MAC address of the root AABBCC000100. So D1 is the root bridge. Go to D2, show spanning tree, and now you can see here the bridge ID. This is AABBCC0002. Okay, and go to A1, show spanning tree space, and the bridge ID, the local, is AABBCC000300. So D1 is the root bridge because the MAC address is the lowest value. Okay, this is 01 is the lowest value. For VLAN 1, the priority is 32,769 on D2. For VLAN 1, the priority for the bridge, the local priority is 32,769, and A1, the bridge ID, the priority is 32,000. For VLAN 1, the priority is 32,769. Okay, they are the same priority, but the difference is the address. So the lowest MAC address is the MAC address of D1. D1 has the lowest base MAC address. Find the root port for each switch. Each switch will have one single root port. This port represents the lowest path cost to the root bridge. Path cost is the total of the port cost in the path to the root bridge. And the port cost is based upon the bandwidth value of the port, and it can either be dynamically assigned or statically configured. As we saw in the previous output show spanning tree route, on each switch the path cost can be different amongst switches. In this case, the path cost from A1 to D1 is 19, reflecting connectivity via fast Ethernet port, while the path cost from D2 to D1 is 4, reflecting connectivity via gigabit port. Okay, cost is 19 for fast Ethernet and 4 for gigabit Ethernet. But on D1 show spanning tree route, D2 and A1. D1 show spanning tree route. D1 is the root bridge, so that's why the cost is 0. And go to D2. Show spanning tree route. The cost is 100 for Ethernet interface, 100 for Ethernet, 19 for fast Ethernet, and 4 for gigabit. And A1 show spanning tree route, also 100. All my links are using Ethernet, okay? Only Ethernet, so that's why the cost is 100. These are direct connections to the root, so port cost and path cost are the same. This can be seen in the output of show spanning tree. Okay, on A1 show spanning tree, show spanning tree. Okay, the cost is 100 on all Ethernet links. Okay, but the root port is Ethernet 01. On A1, the root port is Ethernet 01 because D1 is the root bridge. And also for Ethernet 01, the priority is 2 and is lowest priority than Ethernet 02. The priority is 3. So that's why Ethernet 01 is the root and Ethernet 02 is alternating. Okay, this is the lowest number of the interface and has lowest priority, so is preferred. Okay, remember that Ethernet 02 also connects to D1, but only one interface should be used. And in this case is Ethernet 01 because it's the lowest number. Okay. Our topology does not really illustrate the difference between port cost and path cost very well. So we will introduce a change in the network to achieve this. At D1, shut down the gigabit 101 interface. Okay, in my case is Ethernet 01 on D1, Ethernet 01. And the result of this is that D2 will have to change the port it considers. The result of this is that D2 will have to change the port it considers root, and we will then see the difference between port cost and path cost. Okay, on D1 interface gigabit shutdown. On D1 Ethernet 01 shutdown. D1 configure terminal interface Ethernet 01 shutdown. Okay, shut down that interface. Okay, state down. On D2 issue the command show spanning tree, and you will see the port cost and path cost values separating themselves. Okay, show spanning tree. Okay, and go to D2, show spanning tree, space. Okay, on VLAN 1, look at this, the cost to reach the root bridge is 200. Okay, this is the path cost. Okay, but this link is not available, is shut down, this link is not working. So you have 100 here plus 100. Okay, here 100 and here 100. And this is this link is shut down. Okay, so D2 has a path cost to reach the root bridge. 100 plus 100 is 200. So that's why you can see here the path cost 100 to reach the root bridge. Okay. Okay, so on GNS3, if you will shut down Ethernet 01, it's better to remove the link. Okay, remove the link. Okay, and now go to D2. Also shut down Ethernet 01. Configure terminal interface Ethernet 01. Shut down. Okay, add show spanning tree. And now you can see the cost is 200, 100 plus 100 to reach the root bridge, and the port cost is 100. Ethernet 11 is the port cost is 100. Ethernet 11 the port cost is 100. Okay, and Ethernet 12 is alternating port on blocking state. The root port is on forwarding state, but alternating port is on blocking state. But also the port cost is 100. The root path cost is now 200, while the root port cost is 100 for D2 to reach the root bridge D1. It must traverse two Ethernet links, and 100 times 2 is 200. Identify designated ports. The spanning tree designated port can be tracked back to early versions of the protocol, which were developed when LAN segments were shared multi-access networks. In these networks, there was a very real possibility that there could be users attached to a segment between two switches. The job of the designated port back then was to ensure that users had a way to access the network from a given segment, and there was always one designated port on each segment. In the switched networks of today, there are very few shared segments, so the job of the designated ports is more to help maintain the network topology. A designated port stays active in the topology, but sending BPTUs and learning MAC addresses. Every port of the root bridge is a designated port. Further, there is one designated port on every segment that is not attached directly to the root. If you have not already done so, issue the no shutdown command for D1 interface gigabit 1, and this will restore your full topology to allow for the non-root attached segment to exist, the links between A1 and D2. Okay, so restore the link. Remember, is Ethernet 01 and Ethernet 01. Okay, between D1 and D2, Ethernet 01 and 01. And go to D1, Ethernet 01 was shut down. Remember, also on D2, configure terminal Ethernet 01 not shut down. Okay, and wait a moment, and on D2 issue show spanning tree command, and you will see that there are two ports now identified as being in the designated port role. Show spanning tree on D2, you will have two designated ports. Go to D2 and show spanning tree. For VLAN 1, you have two designated ports, Ethernet 1.1 and Ethernet 1.2. Ethernet 1.1 and Ethernet 1.2. Ethernet 0.1 is the root port. Okay. Ethernet 0.1 is the root port because D1 is now the root bridge. And now look at the segments from the A1 side. Go to A1, show spanning tree, space, for VLAN 1. You will have a root port, Ethernet 0.1. Ethernet 0.1 is the root port because D1 is the root bridge. But these another three ports are alternating ports on blocking state. Okay, so the only one port in forwarding state is Ethernet 0.1. Okay, on A1, the only port on forwarding state is Ethernet 01. So only this link on red is working. Only this link on red is working. And all other links are on blocking state. They are alternating ports. And go to, and on D2, Ethernet 01 is the root port and is on forwarding state. On D2, Ethernet 11 and 12 are designated ports. Ethernet 11 and 12 are designated ports. With the another side, Ethernet 03 and 10 are alternating. Okay, on blocking state. So this link, so these two links are not active. Okay, go to A1. Remember Ethernet 03 and 10 alternating. Interfaces Ethernet 03 and Ethernet 10 on A1 are in the alternate role. Okay, here Ethernet 03 and Ethernet 10. Okay. Interfaces Ethernet 03 and Ethernet 10 on A1 are in the alternate role, which is the Cisco per VLAN spanning tree plus version of the IEEE 802.1d discarding role. These interfaces are receiving BPDUs from the designated ports on each segment, but they will not learn MAC addresses or forward traffic until they stop receiving those BPDUs and move to the designated state. Why is D2 controlling the designated port role on these two segments? Because from the middle of the segment, D2 has a lower cost to the root bridge than those A1. The root cost on D2 is 4, in my case 100, while the root cost on A1 is 19, in my case also 100. Therefore, it takes and maintains the designated ports for these two segments. Okay, on this topology, D2 uses gigabit interfaces, and A1 uses fast Ethernet interfaces. So that's why D2 is preferred for designated ports, and A1 on fast Ethernet ports are blocking state and alternating ports. But in my case, D2 has Ethernet ports and A1 has Ethernet ports. But why D2 is preferred? Why D2 has designated ports and why A1 has the alternating ports? Okay, in this case, D2 has the lowest MAC address than A1. Okay, D2 has AABBCC000200 and A1 is AABBCC0003. So that's why these two is preferred for the designated ports, because D2 has the lower MAC address. Okay, lower MAC address than A1. You may have noticed in the previous output that the two links from A1 to D1 were not being used. Okay, the links from A1 to D1. the links from A1 to D1, this Ethernet 01 forwarding state, Ethernet 02 alternating, Ethernet 01 forwarding state, Ethernet 02 alternating. Each switch can only have a single root port. In this example, the Ethernet 02, which is the alternate role, would only take over if Ethernet 01 were to fail. The decision about which interface to use in this scenario is based on the lowest port priority, which default is 128. That's the interface ID. Okay, for example, on A1, you have Ethernet 01 and Ethernet 02 connected to D1. A1, Ethernet 01 and Ethernet 02. Okay, and Ethernet 01 is preferred because the priority is 128.2 and is lower than 128.3. Implement and observe Rapid Spanning Tree Protocol. You will implement Rapid Spanning Tree Protocol, RSTP, on all the switches. Using the same basic rules, RSTP speeds up convergence significantly. On D2, issue the debug spanning tree events command and then issue shutdown command for interface Ethernet 01 and observe the output on D2. D2 debug spanning tree events. Configure terminal interface Ethernet 01 on D2. This interface Ethernet 01 shutdown. Okay, shutdown. Okay, D2. Enter debug spanning tree events. Configure terminal interface Ethernet 01 shutdown. And to be sure, go to D1 and Ethernet 01 also shut down. D1 interface Ethernet 01 shut down. From the above output, you can see that it took a total about 17 seconds from spanning tree to adjust to the topology change. Rapid spanning tree can adjust much faster. Okay, go to D2, and you can see here the interface administratively down 7, but topology change notice 25. Okay, 18 seconds. 18 seconds. On D1, change the spanning tree mode to rapid per VLAN spanning tree. Okay, go to D1. Exit spanning tree, rapid per VLAN spanning tree. Enter. Okay, spanning tree mode, rapid per VLAN spanning tree. Okay, enter. From the output above, you can see that it took more than 30 seconds for interface VLAN 1 to come back up. There are two conditions that must be met for an SBI to be operational. First, the VLAN the SBI is associated with must exist, and second, the SBI is associated with must be in spanning tree forwarding mode on at least one interface. It took 30 seconds to adjust. What happened to Rapid? You applied spanning tree mode Rapid per VLAN spanning tree on D1, and you can see here from 25 to 29. From 25 to 29, you have only 4 seconds. Okay, only 4 seconds. Okay, from 2025 to 2029, you have only 4 seconds. So that's why Rapid is very fast. But in this case, the interface VLAN 1 changed state to down 1448 and state to up 1519, about 30 seconds. That is why the D1 is the only one switch configured with Rapid, and you need to verify on D1 and later configure D2 and A1 with Rapid per VLAN spanning tree. Okay, and first on D1 show spanning tree to verify on D1 and show spanning tree. And you can see this for VLAN 1, the designated port forwarding state. But look at this type share peer spanning tree protocol. Share peer spanning tree protocol. Okay, but VLAN 1 is using Rapid spanning tree protocol. Okay, a Rapid spanning tree protocol. Before the configuration was IEEE, that is spanning tree protocol, but now is Rapid spanning tree protocol. And you can see the peer is the another switches are using only a spanning tree protocol. The type values tell the story. Rapid spanning tree is backwards compatible with common spanning tree. It achieves this backwards compatibility by failing back to using the timers and settings of common spanning tree. In other words, we will not see the benefits of Rapid spanning tree if only one switch is running it. Okay, on D2 and A1, change the spanning tree mode to Rapid spanning tree. Okay, D2, exit spanning tree mode, Rapid per VLAN spanning tree, enter. A1, enter configure terminal, spanning tree mode, Rapid per VLAN spanning tree. A1 was the last switch that was configured for RSTP. As you can see, interface VLAN 1 was only down for that 0.048 seconds. This is the Rapid in Rapid spanning tree. Ethernet 01 on D2. Okay, interface Ethernet 01 on D2 shutdown. Enter. Okay, sorry, not shut down to enable the interface. Not shut down to enable the interface. Remember, Ethernet 01 was previously shut down and now not shut down. And go to D1, the another side. Also use interface Ethernet 01, no shutdown. Okay. And now go to D2 and shut down Ethernet 01 again. Okay, D2 interface Ethernet 01 shut down. And now you can see this from 10.052 to 10.064. The difference is 10.064 minus 10.052 is only 0.012. Okay, is close to 0.048. My case 0.012. Okay, this is the rapid spanning tree. Okay, thank you very much.